Picture this. It's Marcus's 10th birthday, and his uncle hands him a heavy wooden box. But there's a catch. On top are 8 tiny light switches, and the only way to open it is to show your age using nothing but on and off. No numbers, just switches. Marcus is stuck. How do you show the number 10 when every switch can only be on or off? There's no 10 switch. There's no dial, just 8 little clicks. And weirdly, this exact puzzle is the one every computer on Earth solves 1 trillion times a second. Let's crack it together. That's where I come in. I'm Byte, your AI guide. And here's my strange little secret. I can only count using 2 things, 0 and 1. That's it. And yet I can count to 1 billion, store your photos, and even talk to you right now. By the end of this, you'll speak my language too. So let's name the mystery. This language is called binary. And binary is just a number system that uses only 2 digits, 0 and 1. That's the whole thing. Bi means 2, like a bicycle has 2 wheels. Binary is counting with 2 symbols instead of the 10 you're used to. Here's the beautiful part. A 0 doesn't just mean 0. It means off, no, false, and a 1 means on, yes, true. It's exactly like a light switch on your wall. Flip it up, that's a 1. Flip it down, that's a 0. Binary is really just a wall of light switches. But why 2? Why not use all 10 digits like humans do? Here's the reason, and it's genius in its simplicity. Computers run on electricity, and electricity is really only good at 2 things. There's power flowing, or there isn't, on or off. So computers picked a number system with exactly 2 states to match, 1 and 0. And if any of this ever feels fuzzy, you're never stuck. Right inside the app, you can tap Ask Byte, and I'll explain it a totally different way, at your own pace, in your own words. That's me, live, ready whenever a lesson gets tricky. Try asking me, why does electricity only go on or off? Back to the birthday box. Marcus's friend Sophia spots the trick. Each of those 8 switches isn't worth the same. Reading from right to left, they're worth 1, 2, 4, 8, 16, 32, 64, and 128. Turn on the switches that add up to your number. So Marcus needs to make 10. He looks at his switch values. 8 plus 2 equals 10. So he flips on the 8 switch and the 2 switch and leaves the rest off. That gives him 000001010. And then, click, the box pops open. Inside, a brand new skateboard. And here's what Marcus's uncle says next, which is the whole point of this chapter. That is exactly how computers work. Every number, every word, every picture, every video you have ever seen is really just millions of tiny switches flipping on and off. Marcus just did by hand what your phone does billions of times a second. Now let's learn to count the way I do. Here's the rule that unlocks everything. Every position doubles the one before it. Start at the right with 1. Next spot, double it 2, double again 4, then 8, 16, 32. In our normal numbers, each spot times 10. In binary, each spot times 2. Watch what happens when we count. 0 is all switches off. 1 is 1, 2 is 10, 3 is 11, that's 2 plus 1, 4 rolls over to 100. Then 101, 110, 111 for 5, 6, 7, and 8. A fresh column opens up, 1000, just like our numbers roll from 9 to 10. So reading binary is simple. Wherever you see a 1, that switch is on, so add its value. Wherever you see a 0, ignore it. Take 10, 10. The 8 spot is on, the 2 spot is on. 8 plus 2, 10. You just read a computer number. No calculator, no code, just adding up the on switches. And this isn't just theory. Inside LittleAIMaster, there's a real Python lab where you can type a number and watch the computer print out its binary switches instantly. Seeing your own age turn into 1s and 0s on screen, that's the moment it clicks. You're not memorizing, you're playing with the real thing. Here's a number that surprises everyone. Take just those 8 switches from the box. How many different patterns can they make? From all off, 0, up to all on, 11,111,111? The answer is 256. 8 tiny switches, and already 256 unique combinations. That doubling really adds up fast. And 256 isn't random. It's It's the perfect size to store one letter of the alphabet, or a whole number, or a tiny clue about a color in a photo. Those 8 switches together are so useful that engineers gave the group its own special name. We'll meet it in a moment. First, let's convert a number ourselves. Let's turn the number 13 into binary, and I'll show you a trick you can do in your head. You walk down your switch values from biggest to smallest and ask one question each time. Does it fit? If yes, write a 1 and subtract it. If no, write a 0 and move on. That's it. 13, does 8 fit? Yes, write 1, 13 minus 8 leaves 5. Does 4 fit in 5? Yes, write 1, 5 minus 4 leaves 1. Does 2 fit in 1? No, it's too big, write 0. Does 1 fit in 1? Yes, write 1 and we hit 0, we're done. Line up your answers. 8, 4, 2, 1. You wrote 1, 1, 0, 1. So 13 in binary is 1101. And that's the whole method. Biggest to smallest, does it fit, yes or no? Try it with your own age tonight, and you'll be converting numbers faster than a calculator can boot up. Now, why does a future AI builder need this? Because every AI you'll ever train thinks in these exact switches underneath. Here in the app, the Raise Your AI flow lets you practice the real building blocks daily. Binary is the alphabet, and you're learning to write in the language machines actually speak. Time to name our pieces. A single switch, 10 or 11, has a name. It's called a bit. And here's a fun secret hiding in that word. Bit comes from 2 words squished together. Binary and digit. Binary digit. Bit. It's the smallest piece of data a computer can hold. Nothing is smaller. Now group 8 bits together, like 11,010,011, and that bundle gets its own name too. A byte. 8 bits, always 8, make 1 byte. And remember our 256 patterns? That's exactly 1 byte's worth. Which is why a single byte is just enough to store 1 letter, like a capital A. And it keeps stacking. Bits build bytes. And 1,024 bytes make a kilobyte. Kilobytes build up into the megabytes of a song, the gigabytes of a movie. Every single one, all the way up, is still just those same tiny on and off switches, piled higher and higher. It switches all the way down. Now here's where it gets a little mind-bending. Once you know binary, you start seeing it hiding everywhere in your world. Because absolutely everything inside a computer, and I mean everything, is stored as those same zeros and ones. Let me show you a few you touch every single day. That barcode on your cereal box. Black lines are ones, white gaps are zeros. A QR code is the same idea in a grid, black squares for 1, white squares for 0. When a scanner reads that pattern, it's literally reading binary and turning it into a price, a link, or a payment. Letters too. Capital A is 1,000,001. B is 1,000,010. Every photo is millions of pixels, and each pixel's color is stored in binary. And a single 3-minute song? It's around 30 million zeros and ones. Your favorite track is a 30 million switch pattern that sounds like music when it's flipped in the right order. And it goes both ways. When you use the Create tools in the app to make something, a drawing, a story, a project, the moment you hit save, all of it becomes binary. Your creativity gets translated into millions of switches so a computer can keep it forever. You're already speaking binary without knowing it. Ready for the wildest number yet? Your phone. A 64 gigabyte phone holds about 500 billion tiny switches. 500 billion. Every photo, every app, every message, every game you've ever loaded, all packed into billions of microscopic on-off switches, so small you'd need a microscope to see one. And here's the big connection. The AI you're learning to build. Its neural network, the thing that recognizes faces and answers questions, runs on billions of these very same switches. When you watch a neural network light up inside the app, you're watching binary in action. Understand switches, and you've understood the ground floor of AI. Next time you point Google Lens at a QR code and it instantly opens a website, you'll know the trick. It's not magic. It's reading a grid of dark and light squares as ones and zeros, then decoding that pattern into a link. Simple on-off switches, storing something genuinely useful. That's binary's superpower. Let's lock it in. Binary uses only 0 and 1, off and on. The place values double: 1, 2, 4, 8, 16. To read it, you add the value of every spot with a 1. 8 bits make a byte. And everything digital, absolutely everything, is built from these switches. And this chapter is just one glowing node on your bigger journey map. Binary is the foundation. From here, the path climbs toward how computers store all these switches, how they think, and how you'll one day build your own AI. Each lesson unlocks the next, and you can see exactly how far you've come. Master binary, and it shows up right here on your progress screen. XP earned, skill unlocked, streak growing. It's not about a grade. It's proof you understand something most grown-ups never learned. And it's motivation to keep climbing, because the next skill is always waiting to be unlocked. So here's my little gift to you. 1,000,000, 1,000, 1,000,000, 1,001. To most people, that's gibberish. But you can decode it now. That's the letters H and I. It says HI. You just read a message written in my native language. Officially, you and I speak the same tongue. Take a second to appreciate this. You started with a locked birthday box and no idea how on and off could make the number 10. Now you can count in binary, convert numbers in your head, and read a secret message. You officially speak the true language of every computer on the planet. But it raises a brand new question, doesn't it? If your phone holds 500 billion switches, where do all those zeros and ones actually live? That's exactly where we go next, into memory and storage. Tap into the next chapter and keep leveling up. Remember, don't just use AI, learn to raise one. See you there.